It's not a Hollywood disaster, it's not the end of civilization, it's not the apocalypse. It is the strongest geomagnetic storm Earth has experienced since 2003. In May 2024, the Sun launched a barrage of enormous eruptions directly toward our planet. Within hours, government agencies, satellite operators, airlines, and power companies around the world were watching the same data. Not because Earth was about to be destroyed, but because space weather had just reached NOAA's highest warning level, G5. Extreme. The last time that happened, smartphones didn't exist. Social media didn't exist. Thousands of satellites weren't orbiting Earth. Today, almost every part of modern civilization depends on technology vulnerable to the sun. No guessing, just the facts. And the incredible part is this: most people never realized anything unusual was happening. They saw beautiful auroras. Scientists saw a global stress test. Power grid engineers monitored transformer currents. Satellite operators watched spacecraft orientation. Pilots received updated space weather bulletins. GPS specialists checked navigation accuracy. Because when the sun erupts, the danger isn't the light you can see, it's the invisible storm that follows. A storm carrying billions of tons of electrically charged plasma across nearly 150 million kilometers of empty space. A storm capable of disturbing the magnetic shield that has protected Earth for billions of years. For decades, scientists warned that another extreme solar storm was inevitable. In May 2024, they finally got the chance to see how prepared modern civilization really was. From Earth, the sun often looks calm, a bright yellow circle hanging silently in the sky. But appearances are misleading. The sun is not burning like a giant fire. It is a massive sphere of superheated plasma, nearly 1.39 million kilometers across. Its core reaches around 15 million degrees Celsius. Every second, it converts roughly 600 million tons of hydrogen into helium through nuclear fusion. That reaction releases unimaginable amounts of energy. Most of the time, Earth's magnetic field quietly protects us from the constant stream of charged particles flowing outward from the sun. Scientists call this the solar wind. Normally, it's harmless, but sometimes, the sun becomes far more violent. Instead of releasing a steady breeze of particles, its magnetic field suddenly twists, snaps, and explodes. Those explosions release more energy in minutes than humanity could generate in millions of years. The result is a solar flare, and sometimes, something even larger, a coronal mass ejection, or CME. Imagine ripping a giant bubble of magnetized plasma away from the sun. That bubble can contain billions of tons of solar material racing through space at millions of kilometers per hour. If it's aimed toward Earth, everything changes. Scientists have tracked the sun's activity for centuries. One pattern appears again and again. Approximately every 11 years, solar activity rises and falls. This rhythm is called the solar cycle. During solar minimum, the sun remains relatively quiet. Few sunspots appear. Few eruptions occur. But during solar maximum, the picture changes completely. Dark sunspots spread across the solar surface. Magnetic fields become tangled. Powerful flares become more common. Coronal mass ejections happen more frequently. Solar Cycle 25 officially began in December 2019. Early predictions suggested it would be fairly average, but by 2023, scientists noticed something unexpected. The cycle was becoming stronger than many models had predicted. The number of sunspots increased rapidly. Large active regions appeared one after another. Solar flares became more frequent. Space weather forecasters knew the sun was entering one of its busiest periods in decades. Still, no one knew exactly when the next truly historic eruption would occur. Then came May 2024. In early May, astronomers began watching an enormous sunspot group rotating into view. It received the designation Active Region 3664, or simply AR 3664. At first glance, it looked like a collection of dark patches. In reality, each sunspot marked an area where magnetic forces had become extraordinarily intense. Some of those spots were several times larger than Earth itself. Inside AR 3664, magnetic field lines twisted around one another like tightly wound rubber bands. The longer they twisted, the more energy they stored. Scientists recognized the warning signs immediately. This wasn't just another active region. It had the potential to unleash multiple powerful solar flares. Every major solar observatory focused its instruments toward the growing magnetic monster. Because everyone knew one thing. If AR 3664 erupted while facing Earth, the consequences would not stay on the sun. They would be heading directly toward us. While millions of people looked up at glowing skies, engineers looked down at computer screens. Inside control rooms across the world, numbers began changing. Tiny fluctuations, small anomalies, unexpected magnetic currents. This is the side of a solar storm most people never see. Auroras are only the visible symptom. The real effects happen inside technology. Every long power line, every communications cable, every satellite orbiting Earth exists inside the planet's magnetic environment. When that environment suddenly shifts, electricity begins flowing in places it normally shouldn't. Scientists call these geomagnetically induced currents, or GICs. They're invisible, silent, but under the right conditions, they can overload equipment designed for a much calmer planet. That is why utility operators don't wait until the lights go out. They prepare before the storm arrives. Because prevention is always easier than recovery. Modern power grids stretch for thousands of kilometers. Those long transmission lines are incredibly efficient, but they also act like giant antennas during geomagnetic storms. As Earth's magnetic field fluctuates, electric currents can be induced inside those lines. Most of the time, the currents remain small. During an extreme event, they can become significant enough to stress high-voltage transformers. Transformers are among the most important, and most expensive, components of any electrical grid. Some weigh hundreds of tons. Many take months, even years to replace. That is why power companies closely monitor space weather alerts. During the May 2024 G5 storm, grid operators across North America and Europe increased monitoring, adjusted operations where necessary, and closely watched transformer performance. The encouraging news: the systems largely held. No widespread continental blackout occurred, but engineers gained something almost as valuable: real-world data from the strongest geomagnetic storm in more than 20 years. Every measurement helped improve future planning. No guessing. Just the facts. High above Earth, another challenge was unfolding. Thousands of satellites orbit through the upper atmosphere every day. Most people imagine space as completely empty. It isn't. Even hundreds of kilometers above Earth, traces of atmosphere remain. Normally, they're extremely thin. But during a powerful geomagnetic storm, the upper atmosphere heats up. When it heats, it expands. That expansion increases atmospheric drag. To a satellite traveling nearly 28,000 kilometers per hour, even a tiny increase in drag matters. It slows the spacecraft, changes its orbit, requires additional fuel to maintain altitude. Satellite operators carefully tracked these changes throughout the storm. Some missions adjusted their calculations. Others delayed planned maneuvers. Every operator wanted the same thing: keep spacecraft stable until Earth's atmosphere calmed down again. Not every consequence of a solar storm is visible. Some appear as brief interruptions in signals we use every day. GPS satellites depend on radio waves traveling through Earth's ionosphere. During geomagnetic storms, that layer of charged particles becomes turbulent. Radio signals can bend, slow slightly, or become less accurate. For everyday navigation, most people notice nothing. But industries requiring extreme precision, surveying, agriculture, scientific research, can observe measurable effects. High-frequency radio communications also become less reliable. That matters most for aircraft flying near the polar regions. Airlines routinely monitor space weather forecasts because polar routes depend heavily on radio communication. During stronger solar events, operators may adjust routes or communication procedures as conditions change. Again, preparation is everything. By the time the storm began weakening, researchers around the world had collected an extraordinary amount of information. Satellites recorded changes throughout near-Earth space. Ground observatories measured magnetic disturbances across continents. Power companies analyzed grid behavior. Atmospheric scientists measured expansion in the upper atmosphere. Radio specialists examined signal disruptions. Every dataset added another piece to the puzzle. The May 2024 Gannon storm was not remembered because civilization failed. It was remembered because civilization was tested. It became one of the most closely studied space weather events of the modern era. And perhaps its greatest lesson was this: Earth survived not because the storm was harmless, but because decades of scientific research gave humanity time to prepare. Yet one question still remained: If this was the strongest storm since 2003, how powerful was the storm that all scientists still compare everything against? To answer that, we have to travel back more than 160 years, to a time before electricity powered the world, to an event that still defines the worst-case scenario, the Carrington event of 1859, long before smartphones, long before satellites, long before modern power grids. The sun reminded humanity that space weather is not a new phenomenon. On September 1, 1859, British astronomer Richard Carrington was sketching a group of sunspots through his telescope. Suddenly, he witnessed something no human had ever recorded before. Two brilliant flashes of white light erupted from the sun's surface. The event lasted only a few minutes. Carrington didn't know it then, but he had just witnessed the first recorded observation of a solar flare. About 17 hours later, far faster than most CMEs travel, the resulting solar storm struck Earth. What happened next shocked the world. The skies exploded with color. Auroras appeared so far south that people in the Caribbean, Central America, and parts of northern South America reported seeing them. Newspapers described nights so bright that people believed dawn had arrived. Some miners reportedly woke up, prepared breakfast, and began work because they thought morning had come. But the beauty came with consequences. Telegraph systems, the internet of the 19th century, began failing across Europe and North America. Operators received electric shocks. Some telegraph papers caught fire from electrical surges. In several cases, telegraph systems continued operating even after their power supplies were disconnected, because currents induced by the geomagnetic storm were flowing through the wires themselves. It was the first clear demonstration that the sun could directly affect human technology. The obvious question is, did the May 2024 Gannon storm approach the intensity of the Carrington event? The answer is no. The May 2024 storm reached G5, NOAA's highest operational category, but the G5 scale does not distinguish between all extreme events. The Carrington event is widely believed to have been significantly more powerful than the storms of both 2003 and 2024. Exactly how much stronger remains uncertain. Scientists continue studying historical records, ice cores, tree rings, and magnetic measurements to better estimate its true intensity. That uncertainty is important. No guessing, just the facts. What researchers do know is that the Carrington event remains the benchmark against which every modern solar storm is measured. And fortunately, May 2024 did not reach that level. Before 2024, the last time Earth experienced a G5 geomagnetic storm was during the famous Halloween storms of October and November 2003. Those storms arrived during solar cycle 23 and became one of the most disruptive space weather events of the satellite era. Power systems experienced localized problems. Some satellites entered safe mode to protect sensitive electronics. GPS accuracy degraded in certain regions. Radio communications became unreliable. Airlines adjusted some flight operations, particularly on polar routes. Researchers also observed increased atmospheric drag affecting spacecraft. The Halloween storms transformed how governments viewed space weather. After 2003, forecasting systems improved dramatically. More satellites monitored the sun. Computer models became more accurate. Power companies developed new operating procedures. International cooperation increased. Those investments would prove invaluable 21 years later, because when the Gannon storm arrived in 2024, the world was far better prepared. This is perhaps the most important question of all. Could another Carrington-class event occur? Scientists believe the answer is yes, not because one has been predicted, but because the sun has produced extreme storms before. Solar activity follows natural cycles. As long as the sun remains an active star, powerful eruptions will continue to occur. The difficult question is not if another extreme storm will happen. It is when. That could be years from now. It could be decades. Or much longer. No one knows. And that uncertainty is exactly why agencies like NASA, NOAA, ESA, and power grid operators continue investing in space weather forecasting. Every improvement in prediction provides more time to protect satellites, more time to adjust electrical grids, more time to reroute aircraft, more time to prepare. Because in the world of space weather, even a few hours can make the difference between a manageable event and a much larger problem. The sun had issued a warning. The question now was whether humanity would continue listening. Every morning, the sun rises exactly as we expect. Warm, bright, familiar, it feels permanent, predictable, safe. But beneath that calm appearance is a star, powered by nuclear fusion, constantly reshaping its own magnetic field. The May 2024 Gannon storm reminded scientists of something they have known for decades. Space weather isn't rare. It's part of living beside an active star. Every second, the sun releases energy. Every day, charged particles stream across the solar system. Most of the time, Earth's magnetic field quietly deflects them. Most of the time, we never notice. But sometimes, the sun reminds us that it is still in control, not through explosions we can hear, not through flames reaching Earth, but through invisible magnetic forces traveling across nearly 150 million kilometers of space. The Gannon storm wasn't extraordinary because it was impossible. It was extraordinary because it showed what happens when one of nature's most powerful processes meets a civilization built on electricity and satellites. Scientists often say that every major event is also an experiment. The Gannon storm became one of the most valuable real-world tests of modern infrastructure. Researchers compared forecasts with actual observations. Power companies reviewed grid performance. Satellite operators analyzed orbital changes and spacecraft behavior. Atmospheric scientists measured how much the upper atmosphere expanded. Radio engineers studied disruptions to communication systems. Every observation improved future forecasting models. Every measurement reduced uncertainty. The storm also demonstrated how far space weather science has progressed. In 1859, humanity had almost no warning. In 2003, forecasts were improving but still limited. By 2024, scientists could track solar eruptions from multiple spacecraft, model their trajectories, and warn governments and industries before the storm reached Earth. No forecast is perfect, but today's predictions are more accurate than ever before, and they continue to improve. No guessing, just the facts. The May 2024 storm occurred during the peak of solar cycle 25, a period of heightened solar activity. Although the cycle has passed its most active phase, the sun does not simply switch off overnight. Large sunspot regions can still appear. Powerful solar flares can still erupt. Coronal mass ejections can still be launched toward Earth. Scientists will continue monitoring the sun every hour of every day. Missions such as NASA's Solar Dynamics Observatory, the Joint SOHO mission, ESA's Solar Orbiter, and NOAA's Forecasting Network watch our star continuously. Their goal isn't to stop solar storms. That's impossible. Their goal is something much more practical: to understand them, to predict them, and to give humanity as much warning as possible before the next major eruption arrives. Because the next storm is not a question of belief, it's a question of time. The story of the Gannon storm is not really about danger, it's about perspective. For centuries, humanity looked at the sun as a symbol of stability. Today, we know it is something far more dynamic. A living star whose magnetic heartbeat reaches every planet in the solar system. In May 2024, that heartbeat became unusually powerful. It painted the night sky with extraordinary auroras. It tested satellites. It challenged power grid operators. It reminded scientists that space weather is not science fiction. It is part of everyday reality. And perhaps the most remarkable lesson is this: despite the size of the storm, despite its global reach, humanity did not face it blindly. Thousands of scientists, engineers, forecasters, and operators worked together across continents, turning years of research into practical action. That preparation made all the difference. The next great solar storm will come. Whether it arrives in 5 years, 20 years, or 50, no one can say. But when it does, the lessons of 1859, the lessons of 2003, and the lessons of the 2024 Gannon storm will help guide the response. Because our civilization may depend on electricity, it may depend on satellites, it may depend on technology, but it will always depend on understanding the star that makes life on Earth possible. The sun gives us light. Sometimes, it also gives us a warning, and the wisest thing humanity can do is pay attention. No guessing, just the facts. End of documentary.